All right, we're given a few functions. These are quadratic functions, and we want to know a little bit more information about their graphs. So the very first thing is, you'll notice that we have two different formattings here. We have the standard form, or vertex form, and then we have the general format. All right, both of these, though, a few of these, let's say the how we find the information differs a little bit, but we should be looking in similar places for each one of these. The first question, does it open up or does it open down? In both these cases, this depends on A. All right, A is located out here for the standard form. If it's positive, it opens up. If it's negative, then the graph has been flipped upside down. There's been a vertical reflection. So on the one on the left, A is negative, so it's going to open down. A in this other one, though, it goes ax squared plus bx plus c, so in that case, A is going to be positive, so that parabola opens up. All right, next, let's think about finding the vertex. The vertex on the left-hand side is going to be actually pretty easy. At least I like to think of this as being easy, that the x squared graph has been moved around. Now this is going to flip it upside down. This would be a vertical stretch, thinking about transformations, but when we attach a number directly to x, that's going to be a horizontal movement. So what's happening here is we're adding directly to x. That actually works the opposite direction you think it should. So because we're adding, that actually, instead of moving to the right, it moves to the left 6 units. And the x squared graph, its vertex normally started at the origin, so it's been moved to the left 6. Now at the end here, we're adding 27 to the entire function. So that's going to be a vertical transformation. It's actually going to move everything up 27 units. So that puts our vertex at -6, +27. Again, this will be a left movement, and this will be an up movement. Okay, the vertex for the right-hand one is a little bit different, that we kind of rely on a formula to help us out. Now, typically we call a vertex HK. We give it that designation where H can be defined to be -b over 2a. So again, ax squared plus bx plus c. So in our case, we can say that's going to be -28 over 2 times 2, right? A is here, B is here. All right, a little bit of simplifying down, and we'll get -28 divided by 4, I believe gives us -7. So the x value for our vertex is -7, but we need a y value to go with that. So to get the y value, if you have an x value and you have a function, we're going to replace each one of the x's with -7 to find our y value. So our y value in this case is going to be given by 2 times -7 squared plus 28 times -7 plus 90. Let me zoom in to see my work as we go along here. So that's 2 times 49. And because we have a +28 and a -7, that's going to be a subtraction. 28 times 7 is going to be 196 plus 90. All right, so 2 times 49, 98, minus 196 plus 90. 98 minus 196 plus 90, working it out real quickly, y value is going to be -8. So our vertex there was -7, -8 for that one. Okay, the other questions are similar work, but a little bit different as far as we approach each one of them. So on the left one, if we want to find x-intercepts, x-intercepts are always going to occur whenever our y value is 0. And that's true no matter which version of these you're given. So what we're going to do is replace the y in each one of these with 0. And then solve these down for x. All right, so let's approach this one first. As we're trying to work through this, what I would suggest is let's make this into a power equation. By that I mean I want to isolate this part that is raised to the exponent. So to do so, let's first go ahead and subtract 27 from both sides. So -27 equals negative 3 times the quantity x plus 6 squared. All right, next, we want to isolate the part that's squared. Well, that exponent's only attached to the set of parentheses and not the negative 3 in front. So to get rid of that, I'm going to counteract the fact that it's multiplied by the set of parentheses. I'm going to divide by it. And in doing so, it goes away. On the left-hand side, we can now say, let me see, negative 27 divided by negative 3 makes 9 is x plus 6 quantity squared. All right, so we've isolated the power, right? Made it a power equation. Next, I want to get rid of the square by applying a square root to both sides. When we apply a square root to both sides, we want to remember to use a positive and negative on that constant side. This will reduce down a little bit, so we'll get positive or negative 3 equals x plus 6. All right, so really this means negative 3 equals x plus 6, and positive 3 equals x plus 6. If it's easier to see, make them separate equations and then try to solve down. So in this case, we'll subtract 6 from both sides, so we get x equals negative 9. We'll also subtract 6 over here, so we get x equals negative 3. So we have two x-intercepts in this case. They would go as negative 9, and our y value, remember from over on the left, was 0 for all these x-intercepts, and then negative 3, 0 as well. All right, the x-intercept over here is going to be a little bit more difficult, maybe, but we have a quadratic equation. I would first try to factor this, all right? So looking at this, I see that all three of these terms have a common factor. We already have 0 on one side, so let's look for our greatest common factor. So they all have 2 in common for all three of those terms. So I think 2 times x squared gives us 2x squared, plus 14x gives us that 28x if I distribute the 2, plus 45 gives us 90. All right, from here, I'm hoping that we can continue factoring, but we'll see. If it will factor, it'll split into two binomials where x times x gives us the first term, but then we want to figure out what two numbers multiply and give us 45. So I'm going to go ahead and list 45 off to the side and all the ways to factor that. 1 times 45, 2, 3 times 15, 5 times 9. And I think those are all the different possible ways to factor 45. All right, from there, we want to look at the sign on here is positive. So I'm looking for the pair that adds together and makes that middle number. So in our case, 1 and 45 make 46, 3 and 15 make 18, but hey, look at that. 5 and 9 add together and make 14. So we're going to use 5 and 9 as our second terms in each one of these binomials. All right, we have to make sure that these actually add together and make positive 14, so I think we have to go with positive in this case. Let's go ahead and solve the rest of the way down. Now setting 2 equal to 0 isn't going to give us a solution because we don't have a variable. So let's set x plus 5 equal to 0 and x plus 9 equal to 0. Solve these down. In this case, subtract 5. In this case, subtract 9. And get our two x-intercepts. So in this case, it's going to be negative 5, 0, and negative 9, 0. All right, the last piece of the puzzle on this is trying to find y-intercepts. So all y-intercepts are going to occur when x equals 0. So again, we have an x value. We have a function. We're going to replace the x in the function, or each of the x's in the function, with 0. So on the left one, we get y equals negative 3. Times 0 plus 6 quantity squared plus 27. And on the right one, we're going to go y equals 2 times 0 squared plus 28 times 0 plus 90. Now the one on the right-hand side is going to be fairly easy, right? We have 0 plus 90. Well, 0 plus things is going to be easy. We get 90. So that's the ordered pair 0, 90. On the left-hand side, it's going to be a little bit more work, but it shouldn't be bad either. All right, we're going to follow order of operations and work what's inside the parentheses first. So 0 plus 6 makes 6. Next, we're going to go ahead and apply an exponent. Please excuse my dear Aunt Sally, right? So 6 squared is 36. Then we're going to multiply before we add. So 3 times 36, y equals 108. Negative 108, be careful there, plus 27. So eventually we're going to get negative 81. So again, as an ordered pair, that was an x value of 0, a y value of negative 81, and that concludes this problem. So I hope this helps out as you're trying to work on these problems. Yeah, good luck.